Okay, number 11. So my problem to graph is y equals 2 secant of 1/6 x. So just like the one before, this one does have an amplitude change though, so we're going to graph y equals 2 times the secant of 1/6 times x. Okay, so I need my period, my key points first. So my period is 2 pi divided by b, 1/6. So 2 pi divided by 1/6 is the same thing as 2 pi times 6/1, or 2 pi times 6, which is 12 pi. All right, if I divide my period into 4 equal parts, every 3 pi, that's how much is going to separate my key points. And I also have the amplitude change on this one of amplitude is 2. Okay, so let's graph that. No horizontal shift, so I'm starting at 0. First key point is going to be at 3 pi, and then 6 pi, and then 9 pi, and then it all ends at 12 pi. All right, amplitude 2, so 1, 2. So the graph should oscillate between +2 and -2. This is a secant graph, so it starts at the maximum, and then 0, minimum, and then 0, and then back to the max. So remember, I like to use a broken line so that you don't get fooled into thinking this is actually part of the secant graph. But wherever the cosine is 0, the secant is undefined. So that places my asymptotes for me. And then again, the reciprocals of all these, reciprocal of all these form this, and the reciprocal of this forms. And so this is what the graph is going to look like. All right, so if we, first of all, let's check the period. It should go from 0 to 12 pi, and this one does. See if there's any other ones that do. Yeah, there is. Okay, so I got these two. So it's one of these two. Notice my first from between 0 and 3 pi opens up, and then between 3 pi and 9 pi opens down. So that rules this one out. So it has to be this one. So that one matches exactly what mine does. Okay, 12, now we get over into the tangent and cotangent functions. So we're going to graph one cycle of the graph 2 plus 1/2 cotangent of pi thirds x. First thing to remember when you're graphing tangent and cotangent is the only two functions of the 6 that don't have a period of 2 pi. So when you're dealing with the period of tangent cotangent, the period is pi. So remember, after halfway around the circle, the values start to repeat themselves. So you complete one cycle. The function assumes all of its values in half of a revolution, which is pi. All right, so period. So this time instead of 2 pi divided by b, we do pi divided by b. So pi, b being pi thirds, pi divided by pi thirds is the same thing as pi times 3 over pi. So basically the pi's cancel and we end up with 3 radians being our period. So as I'm graphing this, there's been no horizontal shift. So the graph of cotangent, the plane cotangent x graph has asymptotes 0 and pi. So it actually begins the period at 0 and ends at a pi. So we'll still begin at 0 because there's been no horizontal shift. So we'll have an asymptote at 0. But instead of the other asymptote being at pi, it's now at 3. So it is, pi is just 3.14. So it's just had a very slight shrinking horizontally. So we'll say this is 3 radians. But with tangent, cotangent, at the beginning and end of their cycle, they always begin and end with asymptotes. In the middle of their period is where their x-intercept is. So I would end up with crossing the x-axis at 3/2, 1.5. And I also have the vertical shift up of 2, so I got to take that. So let me go ahead and I'm going to kind of put my x-axis shifted up here, that way I don't forget to shift up 2. So really it's going to be crossing here. It would have been here had it not been for the vertical shift. But and then typically at the other key points, the graph is either at 1 or -1. So our cotangent is decreasing unless there's a negative there. So it is going to be at instead of 1, though, it's got the multiplier. We don't really call that an amplitude, so it would be at 1/2, -1/2, and so it would come down like this. Okay, so it's going to be between 0 and 3. Right in the middle is going to be the x-intercept course, it's been shifted up 2. So it will actually be at 2, 2. And then if this were the x-intercept, this would be like your amplitude 1 and -1, except for the amplitude has been compressed, so we will only go up 1/2 and down 1/2. Or if it's tangent, it would be increasing, it would go the other way. So this is what the graph should look like. And if I'm looking at my choices, they all 4 have a period of 3. The first one they shifted it down 2 instead of up 2. So they did on the 2 left-hand options. And the 2 right-hand options are both, I'm sorry, the first one and the last one are the ones that are both decreasing like this. The difference between them is the first one is shifted down 2 instead of up 2. So on mine, the answer is the last option. Looks just like my graph here. So once you get this, you can easily match it to the choices on the screen. Okay, 13, we are asked to find the equation that matches this graph. Okay, and so as I'm looking at this graph, it looks like a basic sine or cosine wave. If there's been no horizontal shift, it's going to be a cosine function. So I am going to, that'd be the easiest thing to for sure use. So a cosine graph. Now, there's been no horizontal shift. If we start at 0, cosine's at its maximum 0, minimum 0. So it looks like a pretty simple cosine graph. It does have a period change, but there's been no shift. So I'll just leave this to put the something times x. I got to figure out what the multiplier is. It also has an amplitude change, and that was pretty easy. Well, no, it doesn't have an amplitude. It's just 1. It looked like it was stretched out there, but so there's nothing there. It's just 1. Really, all that comes down to is finding the period, or using the period to find out what the b value is. Okay, and so remember, the key to that is 2 pi divided by b equals your period. All right, my period, I can look and see it goes from 0 to 12 pi. It completes the cycle of the graph in 12 pi radians. So I know my period. So I just need to figure out 2 pi divided by what equals 12 pi. And when you solve that, that's your b. You're going to fill that in, and that's your equation. You're done. So just to do a little algebra here to solve that, let's multiply both sides by b. And so I end up from here with 2 pi equals 12 pi times b. Then I'll just divide both sides by 12 pi. And that should be my b value. So b is equal to, the pi's will cancel out, and I can reduce 2 12s to 1/6. And so my b value, which is the multiplier of the angle, is 1/6. There's my equation for this graph. Y equals cosine of 1/6 x. This is number 14. So on mine, this is what the graph looks like that I am trying to write the equation of. So again, your graph will be a little bit different, but process same. All right, so as I'm looking at this graph, let's just kind of examine the graph for a minute here. The starting at 0, going to its maximum, back to 0, minimum, back to 0, that's the sine wave. So without any horizontal shifting, which makes it a lot easier to write the equation, starting at 0, this would be modeled by a sine graph. So let me start with y equals, I'll leave a space there in case the amplitude has changed. So let's look, see if amplitude has changed. Well, amplitude is not 1. Now there's been no vertical shift, if you noticed. It's all oscillating around 0. So we don't have to worry about a vertical shift, but I do see the amplitude is 7. And so I will stick the 7 in there. So 7 times the sine. All right, and no horizontal shift, but I do need to determine what b is from the period. So let me look at 2 pi divided by b is equal to the period. And the period of my graph here, so it starts at 0 and it finishes its cycle at pi. So the period's pi. So 2 pi divided by what equals pi. Well, the answer to that is when b is 2. 2 pi divided by 2 is pi. All right, and so I know that b is 2, so 2x goes there. There's been no reflection. There's been no vertical shift. There's been no horizontal shift. That is a graph that would model this. And it's a good idea to always go back and check it. If I were given this to graph it, would it look like this? So I would first find my period. 2 pi divided by 2 is pi. So yeah, I would go ahead and scale my key points. Dividing pi into 4 equal parts would be pi fourths, 2 pi fourths, which is pi halves, 3 pi fourths, pi. The sine graph is going to start at 0, go up to its maximum, which is going to be 7, And yes, this does look like it matches my equation. All right, this one's number 15. Same thing, that we're asked to find an equation to match the graph. Now, in this one, as I look at this, it does appear that this one has a horizontal shift, especially if I want to use a cosine function, because it's certainly what it looks like. If I start my period here, it's a cosine graph. So set its maximum, 0, minimum, 0, maximum. So it really comes down to trying to determine the period, the C and the B in the equation. The amplitude's pretty easy to see, the A. So the amplitude, go ahead and say A, is 6. And there's been no vertical shift since it's oscillating around 6 and negative, from positive 6 to negative 6 there. So it's really just going to be about finding B and C. Okay, so we know B comes from the period. So period, let me just say, do it this way, 2 pi divided by B equals my period. And I'm trying to find B because B is the part of the equation that I need. The period goes from negative 3 pi eighths to 5 pi eighths. So, think about from negative 3 pi eighths to 5 pi eighths, how long is that? What's the distance from negative 3 pi eighths to 5 pi eighths? So you could just quickly, this is 3 pi eighths and this is 5 pi eighths. If we add them together, I get 8 pi eighths, which is pi. So my period is basically pi. And so if I solve that now to find B, 2 pi divided by what equals pi will be is 2. Okay, easy enough. Now, to get my C, remember that negative C divided by B is equal to my horizontal shift. And you can see that since this graph is not beginning its cycle at 0, it's been shifted back where it begins at negative 3 pi eighths. My horizontal shift is negative 3 pi eighths. So I basically need to find the phase, or what C is. So negative C divided by B, so I would have to know B to be able to do that, and I do. And so basically I just need to solve this for C, and I've got my C value, and then I've got everything I need that I can put together to make the equation that represents this. So I'm going to solve this and do division by 2, and I also have a negative there. I'm going to go ahead and multiply both sides by negative 2. That'll take care of that. And so I end up with C equals, this would be 6 over 8, which would be 3 pi fourths. If you reduce it, 6/8 pi, 3 pi fourths. Okay, so this is my B, this is my C, and I said I was using a cosine function with an amplitude of 6. Let me come over here. B is 2, C is 3 pi fourths, and I could put it all together now and say y equals amplitude 6 cosine of bx 2x plus 3 pi fourths. Okay, now it's always a good idea to check it again. So let me just say I was starting with this and work my way back to see, would this be the graph that would result from this equation? So let's start with our period. So 2 pi divided by 2 is pi. That means divide that by 4, every pi fourths, that's how far it's going to separate my key points. The shift is negative C divided by B. So negative 3 pi fourths divided by 2. Negative 3 pi fourths divided by 2 is the same thing as a multiplying by 1/2. Means the graph shifts back to negative 3 pi eighths. Yes, it does. Now, if you keep adding pi fourths, we said pi fourths separates each key point. That's 2 pi divided by B, 2 pi divided by 2, giving the period of pi, and then a fourth of that, so pi fourths. So if I add pi, think of pi fourths as 2/8. So if you keep adding 2/8, so negative 3 pi eighths plus 2 pi eighths is negative 1 pi eighth. Negative 1 pi eighth plus 2 pi eighths is 1 pi eighth. 1 pi eighth and 2 pi eighths is 3 pi eighths. 3 pi eighths and 2 pi eighths is 5 pi eighths. So those are my key points. The cosine starts at the maximum 6, 0, negative 6, 0, 6. Perfect. So this is the equation that would model that graph. Okay, so this problem 16 comes from our section on inverse functions, which was our last section. So remember, first of all, arc sine is no different than inverse sine, so you can write that the same thing would be to say, let me turn this over here, would be to say arc sine would be the same thing as saying sine inverse. Just another way of saying that. Different notation. Okay, I put the little chart here because, and I put know this here because if you don't know this, then you definitely want to memorize this. Learn these. It will save you so much time and trouble of having to remember, of having to go back and derive those each time. So I've said that all along from the beginning of the year. Learn these, know these. It should be something you can roll off without even having to really think twice about it. So basically, inverse sine is asking me, there's an angle that's associated with the ratio of sides opposite to hypotenuse being -3 square root of 3 to 2. I just need to know what angle that is. What angle is associated with square root of 3 over 2? Now, I'm not going to worry about the negative yet. Let's just figure out, is it a 30? If they ask you to do it without a calculator, it's one of the common angles. 30 is 60 or 45. So, or in radians, pi 6, pi thirds, or pi fourths. So the sine is square root of 3 over 2 when the angle is 60 degrees or pi thirds radians. So that's the 60 degree of the pi third one, that it's going to be one of those. That's going to be the reference angle for whatever the angle is. So the inverse sine. Now, the fact that it's negative means that it has to occur. Sine is negative in quadrants 3 and 4. Sine is your y coordinate, and remember y is negative in quadrants 3 and 4. So we're going to look at the pi thirds. The angle is pi thirds in this quadrant or in this quadrant. Now, it can be both of these, and the reason it can be both of these is because if you go back to when you learned inverse functions, you learned that in order for an inverse sine to be a function, we had to restrict the domain so that it had to stay between pi halves and negative pi halves. So that means you can only use a quadrant 1 or quadrant 4 angle. So that rules this one out, which means it's going to be this angle right here. And so this angle from here to here will be listed as negative pi thirds. So the answer to this would be negative pi thirds. Okay, so 17, same thing. It's just this time it's an inverse cosine. So it's critical when you deal with inverses. You have to know the, let me write the function down here. So remember, inverse cosine of 1/2. So we have to know what the restrictions are on the domain for the inverse function. So a cosine, we have to restrict the domain to be from 0 to pi. So it has to be in quadrants 1 or 2. That's what, in order for the cosine to be a function. All right, and if you don't remember why that is, you can go back to the section 4.7, and it's explained in that section why each function we have to restrict the domain on the inverse to make it a function, because the function, it's as it is over the entire domain, all real numbers, is not a function. Okay, so go back to your little chart. If you don't remember, where is cosine? What angle is associated with the cosine of 1/2? Well, it's also a pi thirds or 60 degree angle. Okay, but cosine is positive in quadrants 1 and it's the x, so it's in 1 and 4. So it would be the pi thirds angle here or a pi thirds angle down here. Negative pi thirds or positive pi thirds. But because of the restrictions on the domain, cosine, inverse cosine, only be in quadrants 1 or 2. It has to be between 0 and pi. So that's how I know that it's just plain pi thirds. It is not negative pi thirds. Okay, so we're asking this one, 18, to evaluate, or I am, without, I'm asked, your problem may be a little bit different, but we'll do a couple like this and yours should follow the pattern. Evaluate without using a calculator. The cosine of the angle, so this angle is the angle that's associated with a cosine of 6/7. That's what inverse means. So what angle is associated with a triangle whose adjacent and hypotenuse have a ratio of 6 to 7. So let me draw it. I like to kind of make it visual here, so just so you can see and understand what's happening here. So cosine, what angle is associated with a cosine of 6/7? Well, it could be an angle in quadrant 1, where the adjacent and the hypotenuse have a ratio of 6 to 7. But it could also be in quadrant 4, where the ratio of the adjacent to hypotenuse is 6 to 7. Now, because it's an inverse function of cosine, and cosine inverse is restricted, it has to have a domain between 0 and pi, then it has to be in quadrant 1 or 2. Therefore, it can't be this one. So that's how I know I'm using this angle right here. So this is the angle that they're describing here. Now the cosine of that angle is adjacent to hypotenuse, is 6 to 7. So the answer is cosine of the inverse cosine of 6/7 is 6/7. All right, 19, same thing as just like 18, except the inverse is on the outside this time, so it's a little bit flipped around from that. So I need to find the inverse cosine of the cosine of 5 pi 4. So let me start here to figure out what the ratio of sides adjacent to hypotenuse is for this angle, and then I'll do the inverse cosine of that. So again, I'm going to draw it out and make it visual here so we can see it. Okay, so the cosine, this is just a straightforward cosine of 5 pi 4. So just remember that 5 pi 4 is in quadrant 3, and the reference angle there is pi 4. And so the cosine of pi 4 is square root of 2 over 2. Those are the things that you want to have memorized. So basically this is saying find the inverse cosine of square root of 2 over 2. Oh, and it's negative in quadrant 3, remember. So cosine in quadrant 3 is negative. It's the x-coordinate going left. So, okay, now I need to find the inverse cosine. What angle is associated with a cosine of negative square root of 2 over 2, but in the domain for an inverse cosine, which is from 0 to, so remember it has to be from 0 to pi. Okay, so the angles that would have a cosine of negative square root of 2 over 2 would be the 45 or the pi 4 degree angle. Cosine is negative in this quadrant, so it would be that angle and reference angle there. So this would be at 3 pi 4, and this would be at 5 pi 4. But 5 pi 4 is not in the domain for an inverse cosine. And so I know it's not this one, I rule that out, and so 3 pi 4 would be my correct answer. All right, last function, or last problem on the review. This is problem 20. All right, so my problem on my review said to take tangent of sine inverse of 15/17. Okay, without using a calculator, because these are all common angles. So, or we can do them without a we don't need a calculator to do them. Okay, and so in this one, I'm going to first find what angle is associated with a ratio of opposite to hypotenuse being 15 to 17, and then I'll take the tangent of that. But remember, do remember that for sine inverse, the domain must be between negative pi halves and positive pi halves. Okay, let's draw this out, make it visual. Okay, so sine, to be a positive 15/17 means sine could be in quadrants 1 or 2. Sine is the y-coordinate, it's positive in quadrants 1 or 2, but quadrant 2 does not fall in the domain for inverse. It has to be from 0 to positive pi halves or 0 to negative pi halves. So that would rule this one out. So I'm going to draw it in this quadrant 1. All right, sine, if the sine is 15 to 17, that means the ratio of the opposite side of the hypotenuse is 15 to 17. All right, well, they want me, so this is the angle that is associated with this. This is the angle now that I'm trying to find the tangent of. So the tangent of this angle, well, tangent is opposite over adjacent. I don't have the adjacent side. Okay, so I would have to find the adjacent side to be able to answer this question. So if you know the Pythagorean triple, 8, 15, 17, you don't have to do it. If you don't, no big deal. You just do the Pythagorean theorem and solve that for the missing side. So 17 squared equals 15 squared plus b squared. It just saves you time if you know some of those common triples. So this is 289, this is 225, and that is 64. The difference when I subtract 225 over, and b is 8. Okay, so 8 for the side. So now I can give the tangent, and so the tangent of the inverse sine of 15 over 17. So this angle is this angle, and then the tangent of this angle is opposite over adjacent, 15 over 8. And that is the answer. And that is the last problem on the review.